Good morning, and today we're going to be looking at stationary points within differentiation. Okay, so at some point a curve may be neither increasing nor decreasing. We say that the curve is stationary at these points, so it's neither rising or falling, it's neither increasing nor decreasing. Okay, what that actually means is that the curve is turning at those points. Now remember that dy by dx or f dash of x is actually equal to the gradient, and if you were to draw a tangent at a point where a graph is turning, then it would be a horizontal line that you would have drawn there, and we can say that the gradient would be 0 at a turning point in a graph, so therefore we can deduct that dy by dx is equal to 0 or f dash of x is equal to 0. So the derivative is equal to 0 at stationary points because stationary points are turning points. The nature of the stationary point, whether it's a maximum turning point or whether it's a minimum turning point or even a point of inflection, and I'll explain what that is in a moment, depends on the gradient on either side of it. Okay, so the four possible stationary points are, here we have a maximum turning point, so a maximum, okay, or a minimum turning point. So we can see the graph is going down the way to the turning point, so it's a minimum turning point. This here is a rising point of inflection, so it looks as though it's starting to turn, but it doesn't start to go down the way, it continues. It does turn, but it keeps going in the same direction it was beforehand. And we have a falling point of inflection, which means it's starting to fall, starts to turn, but it doesn't start to go up the way after that. It continues and it continues to fall. Okay. Now, how do we know what kind of turning point we have? Well, we're going to be looking at the behaviour of the graph to the left and to the right of the actual turning point. We're going to use something called a nature table to help us to do this. Okay. So if we look at the turning point here, for example, we can see that to the left of it, the graph is rising. And when the graph is rising, remember that means that f dash of x would be greater than 0 for all of those points because the gradient at any point on that graph would be positive. So f dash of x or dy by dx would be greater than 0 where the graph is rising. And just remember that f dash of x would be less than 0 because the gradient would be negative, going down the way there to show that the graph is falling. Okay, so we'll look at that with a nature table instead of having to draw the graph. So let's do this example. Now these are lengthy questions, so you will have to try to learn the steps so that you can do these without obviously the prompts that are given in the example. Find the stationary points on the curve and determine their nature. So we're going to find where the turning points are and then say whether they're a maximum turning point or whether they're a minimum turning point or a point of inflection. Okay, so the first thing we're going to do is differentiate the function. So here we have f of x and f dash of x is equal to. So we multiply by the power, take one off the power. So we have a 6x squared. Then we have a negative 18x, then a plus 12. And the x has disappeared at this point and the constant disappears. Okay? So we now have f dash of x equals 6x squared minus 18x plus 12. Step 2, find the stationary points. So the stationary points, so you need to, that's the next step. Stationary points occur when f dash of x is equal to 0. Because f dash of x is the same as the gradient, so that makes sense. So we're now going to make our f dash of x function be equal to 0. Now please don't throw away marks by missing out the equal 0 part. Okay, so I need you to make it very clear at this point that you're making f dash of x equal to 0. Now we can take out a common factor of 6 here and then factorise it. So we'll have an x and an x and a 2 and a 1. Just be careful of your order that you put them in. So we have an x minus 1 and an x minus 2. And that leads to x being equal to 1 or x being equal to 2. Okay, so those are where your turning points occur on your graph. Now, we know the x's of the turning points, but we want to find the actual y coordinate as well. Now, you have to remember here that f of x and y are the same thing. So if you want to find what the y value is, you're going to use f of x equals your function here. Put those two x values into that to get your corresponding y. So if x is equal to 1 or x is equal to 2, I'm going to put it into our f function, and that will give us what y is equal to, because f of x and y are the same thing. So we just tidy that up. 2 times 1 cubed is 2, minus 9 times 1 squared is minus 9, plus 12 times 1 is 12, plus your 4, and that gives you altogether a 9, value of 9. So if f of 1 is equal to 9, that means that your y value at x equals 1 is 9. So your coordinate is 1, 9. Now that's a turning point on your graph. Okay, that's what that is. Do the same for the other value, the other stationary point value that we worked out, which was f of 2. So we worked out that x equals 2 is the other turning point. So we're going to work what that is. So we've got 2 times a 2 cubed, which is a 2 times 8, which is your 16, minus your 9 times your 2 squared, minus 9 times 4, plus 12 times 2, plus your 4. Put that together, and we've worked out that the y value at x equals 2 is 8. Okay, so that means that we have the other coordinate, which is 2, 8. So 2, 8 is a stationary point. Okay, so we've now got these two stationary points worked out. So we know that the graph turns at these points, but what kind of turning point is it? And this is where I'm now going to introduce you to the nature table. Okay, so the stationary values go in the top row of the nature table with arrows leading in and out of them. So we start with an x in the corner, and then our two x values for the turning point go in that top row. Okay, remember, for us to work out what the turning point is, we have to look to the left and to the right of the turning point to see what's happening with the graph, if the graph is rising or if it's falling to the left or to the right of the turning point. So we use these little arrows to show that we're looking at the left or the right of the turning points. So then we're then going to calculate f dashed of x for the values in the table. Okay, and we're going to record the results as being either positives or negatives. So we've got f dashed of x. Okay, so we're now going to be working out what f dashed of x is equal to for, first of all, the 1 and the 0. Okay, now we know that we've made f dashed of x equal to 0, and we got the answer 1 and 2, x equals 1 and x equals 2. So we know that's a 0 in there. We know that's a 0 in there. So we can automatically put that f dashed of x is equal to 0 for these 2 points here. So that's how we got those 2 points, by making f dashed of x equal to 0. That means that the graph is turning. The gradient would be 0, which is horizontal. The graph is turning at those points. Now let's look to the left of 1 and see what f dashed of x is doing there. Is it sloping up the way, which would mean it would be positive, or is it sloping down the way, which would mean it would be negative? Okay, so something just to the left of 1, and then something in between 1 and 2, and then something to the right of 2. So we'll pick anything here. We'll pick negative 1. Could have also picked 0. Okay, I'm just picking negative 1 just as a demonstration. But we could have picked 0, which would have been easier. You could have done it mentally. We need to pick something in between 1 and 2. So we'll pick 1.5. We'll pick something to the right of 2. We'll pick 3. Okay, so let's put in negative 1 into f dashed of x and see what it gives you. So 6 times negative 1 squared, take away 18 times negative 1 plus 12. That would be a 6 plus an 18 plus a 12. Okay, right, so we've got a 6 plus an 18 plus a 12. Now the actual numerical value of that doesn't matter. If you can see roughly, the answer is going to be quite clearly positive or quite clearly negative. Now again, if you picked x equals 0 to put in there, then we could have seen that that would have been 0, 0, and that would have just been a positive 12. So we definitely know that to the left of 1 is definitely a positive. So we actually don't even need to put the number in. We just put a little positive sign to show that it's a positive gradient. It's a positive f dashed of x in there. And all the numbers to the left of 1 would have been a positive f dashed of x value. Now this one's a bit more tricky, so we have to be careful with this one. Okay, so we've got 1.5 going in here. Okay, so we put 6 times 1.5 squared, take away 18 times 1.5 plus 12. That turns out to be a negative value. So we don't need the actual number, we just need to put a negative sign in there. Let's work out what f dash of 3 is. You do the same thing, put a 3 into each of the x values for f dash of x, and we end up with a positive value here. So now we're ready to see what the shape of the graph is going to look like. Okay, so we're going to show what the graph is going to look like by just remembering that a positive f dash of x means that the graph is sloping up, and a negative f dash of x means that the graph is sloping down, because f dash of x is the same as a gradient. A positive gradient would begin up, a negative gradient would begin down, and a positive gradient there would begin up. So we're going to look at the graph, or the nature of the graph. So a positive means that the graph is sloping up. A 0 means the graph is sloping across the way, it's a turning point. The negative means the graph is sloping down. Okay, then the 0 means the graph is sloping across, which is a turning point again. And a positive means the graph is sloping up. Okay, so that's what the graph is looking like. So we can see the graph's going up the way, it turns there, and then it starts to go down the way. Now all this is just letting you see is what the nature of the graph is going to be looking like, and we can then state all of that. So we can see that we've got a maximum turning point at this point here. So at x equals 1, the graph is turning, and it's a maximum turning point, but we can see here we've got a minimum turning point here. So at x equals 2, we have a minimum turning point. So we just state the nature of the turning points along with their full coordinate. Okay, so 1, 9 is a maximum turning point, and we can just write this underneath the nature table when we've got all the space and we don't have all the steps written down. So 1, 9 is a maximum turning point, and 2, 8 is a minimum turning point. And that's your question answered. So we have now found the stationary points, we've used the nature table, and we know what kind of turning points they are, and we have determined their nature. Now, this question doesn't actually ask you to sketch the graph. You can get a question that takes it a step further and asks you to sketch it, but you don't have to do that for the question. This is just to let you see what that would actually look like. Now we can see what the graph looks like there. Okay. Just showing you that would be a turning point at 1, 9 and a turning point at 2, 8. It's just to let you see that, but that's not part of your answer. Right, so we're now going to look at exercise 6M. And these are quite lengthy questions, so do as many as you want from this exercise, but if we can at least try to do questions 2, 4 and 6. And again, it just takes practice, so follow the steps that are given in the PowerPoint, but try to memorise the steps as well. Okay, try to make sure that you're committing this to memory, because it is quite a lengthy answer and you have to be able to do this off the top of your head. Okay, so take care, good luck, and ask your teacher if you need any help.